Hello everybody. This week we're going to be talking about patterns of the night sky and identifying objects in the night sky and how we map their motion and try to work out the three-dimensional structure of the solar system by looking at those observations. So that's what we're going to be doing today, and I want to use a program called Stellarium. If you haven't already, you can go download Stellarium at stellarium.org and get a free copy of this program for you to use. To set your location, you can go over to the location menu over on the left and type in your location. In particular, you can look at Ogden, Utah, Ogden, United States. Click on that and that will take you to the location of your choice. You can also go anywhere you like in the world, which is nice. Okay, so here we are in Ogden, Utah, let's get back to sunset here, so we're at a reasonable time. All right, so this is what Ogden looks like, the night sky from Ogden, and we've already showed you how to find north. So you can go ahead and try to identify where the North Star is by finding Big Dipper and finding the North Pole. And what I wanted to do in this tutorial was kind of look at the patterns on the sky. So what is it about the solar system and the universe that we're able to see by looking at this? And let's go ahead and first start by finding the Big Dipper. So let's go a little bit later in the night. There we go. So there's the Big Dipper there. So if I follow this arc to the Big Dipper and then these two lines up here, this, as we recall from last time, is the North Star. So that's Polaris. And Polaris is the star that is directly above what's called the North Celestial Pole. And that defines a coordinate system that is centered on the equator and the poles of the Earth. That's called our equatorial coordinate system. And that's the South Celestial, or the North Celestial Pole there. There's one in the south as well, and the equator is in the middle. So if you're outside at night and you want to try to find where the equator is, the first thing you do is you find the North Star and then put out your arm at 90 degrees to where the North Star is, and that's going to mark the equator. So that's the point on the sky that's directly above the equator. So from where we are, that's going to be in the south. And I'm just going to look to the south here. And the equator is going to cut across this. Now, because we're in Stellarium, we can put that coordinate system on the sky. So I'm going to go ahead and do that. And if you open up this panel at the bottom by bringing your mouse to the bottom, you can click on this equatorial grid, and that'll basically paint the equatorial coordinate system on the sky. So we can see that 0 degrees is right there. That's the equator. The line that if you were at the equator would be directly overhead, going from east to west. Now there's another line I want you to look at, which is how the solar system is oriented with respect to the tilt of the Earth. So if we imagine the solar system as a plate, and if this Earth was oriented like this with its poles sticking straight up, then the equator and the solar system plane would be the same. But because the Earth is tilted a little bit on its axis, they're offset a little bit. And you can find the plane of the solar system, something called the Ecliptic, by going out and finding planets in the night sky, and those will be in a line on the ecliptic. So I'm going to go ahead and turn off the equatorial system just so we can see Jupiter and Saturn here. So here's Jupiter and Saturn, and those are going to be on a line that represents the plane of the solar system. Now it'd be nice if we had a third point to look at, and I don't see any solar system objects up. It would be nice if we had a moon or a sun or something like that. So let me go ahead and take the date and time window, and I'm going to move this a little bit so that we can see where the sun is setting. So the sun is setting over there, and if I imagine a line going through Jupiter and Saturn were over here. What happened to them? I lost them. There they are. Jupiter and Saturn were over here. And if I imagine painting a line on the sky through the sun, that's going to be the ecliptic. So let's go back to nighttime so we can see the stars. Whoops. So there's the Saturn and Jupiter, and if I imagine painting a line across the sky to where the sun is setting, that's going to be the ecliptic. Now, because we're in our Stellarium, I can go ahead and paint that on the sky. Okay, so we can do this by going into the sky and viewing options and click on markings. And inside there, I just need to find the ecliptic. So I'm going to click the ecliptic here, and I see a line that goes across the sky that crosses where the sun is and where Jupiter and Saturn are. So that's the plane of the solar system. So go outside at night and find some planets, and you now know where the plane of the solar system is. So this gives you an idea of how the Earth is oriented with respect to the solar system itself. We're tilted by about 23.5 degrees, and you can see that on the night sky. Okay, the last thing I wanted to talk a little bit about is the phases of the moon, because it's watching the phases of the moon that teach us about the three-dimensional nature of our solar system, in particular how the moon orbits the Earth. So let's go ahead and find our moon. I'm going to go ahead and turn off these coordinate markings first. And I can find the moon by just going into my search function down here, and I can type in moon and hit return, and the moon is currently not up. It's down beneath the horizon. So I can set my date and time to advance forward until the moon rises, and there it is. So this is about 2 o'clock in the morning. This is on August 13th, because I'm doing these a little bit early this year, but this is on August 13th, and you can see that the moon in this particular time of year on August 13th is going to be a crescent moon, and it turns out to be a waning crescent moon because it's rising before the sun does. So let's look and see how those phases work as we look at the orientation of the moon with respect to the sun. So I'm going to go ahead and march my time forward again just so I can wait until sunrise. And if I look at sunrise, zoom out a little bit so you can see the moon. So there's the moon, there's sunrise, and the lit part of the moon always points at the sun. Because half the moon is always lit, it's just we can only see part of the lit part depending on where it is relative to us as it orbits the Earth. So here we're seeing the lit part, and that's like the spotlight of the sun is shining on that, so you can follow that back to where the sun is. And we can see here that it's pointing in the direction of the sun right here. So I'm going to move forward in my date now to get to a time of new moon. And a new moon is when the lit part of the moon isn't visible from the Earth because it's on the other side. Effectively, the moon is between the Earth and the sun, and so we can't see the lit part. So let's go ahead and do that. And if I move to the 14th, you can see that the moon is slightly less illuminated. If I move to the 15th, it's even less illuminated. And if I move to the 16th, it's even less illuminated. And if you're using Stellarium, you can look over here and see that the amount illuminated is now only 8%, right? So I'm going to go ahead and move one more day, and you can see here that now it's illuminated 3%, and it's barely visible, just a little bit of a crescent. If I go one more day, then the moon is located exactly in the direction of the sun. And not exactly in the direction, because the tilt of the moon's orbit is slightly tilted, so it doesn't cross directly in front of the sun every time, otherwise we'd have an eclipse every time. But you can see that it's in the direction very, very close to the sun. And we can't even see much of it at all. And this is where it's only 0.5% illuminated at this point. Now let's go forward in time a little bit so we can see where the sun is. And we'll see if we can get a little bit closer. There's the sun. Okay, so this is, again, like I say, it's not exactly lined up with the sun because otherwise we'd have an eclipse, but the lit part of the moon is facing away from us. If I go ahead and go one more day, we're going to see that the moon is now on the other side of the sun, and still I can't see the lit part because it's new. So when the moon is in the direction of the sun, the lit part of the moon is invisible to us. We call that a new moon. So I can go exactly 2 weeks later, and if I go exactly 2 weeks later, I should get to the point where the moon is roughly half its way through its orbit. In other words, it's on the other side of the Earth relative to the sun, and that's what we call a full moon. So let me go ahead and do that. I'm going to advance this forward a couple of weeks, and then I'm going to move us so we're looking in the other direction, to the west. Oops. And then let's go to sunset. Okay, so here's sunset, and now I want to try and find the full moon. So let's see here, what was, I guess I went too far here. 2 weeks from the 13th, be like that. Okay, so let's go ahead and see if I find the moon. The moon is going to be, when it's exactly full, roughly opposite of the sun. So let's go a little bit, there it is. Okay, so there's the moon now. Let's see how illuminated it is. It looks like it is illuminated by, this is a 90% illumination here, so it is practically full, and it is exactly on the opposite side of the sun. Okay, so let's see if we can get this to exactly full so we can really see what happens here. Let's go a little bit further. Oops. Not quite. There it is. Okay, so there's the moon now, and that's illuminated 95%, close enough. So there's our full moon rising in the east at the exact same time that the sun is setting in the west. There's the sun over there, and so the moon and the sun, with us, Earth in the middle, are exactly opposite, and we're seeing the fully illuminated side of the moon. That's what we call a full moon. And you can always tell it's a full moon because if the sun is rising and the moon is setting, or if the moon is rising and the sun is setting, then it has to be on exactly the opposite side, and therefore it should be a full moon. And by the way, you can very clearly see the line of the ecliptic passing through the sun, Jupiter, Saturn, and the moon. Now this is going to happen our full moon is going to happen on August 30th, which is just after when school starts. And if you go outside at about 8:15, you should see this configuration of moon, Saturn, Jupiter, and the sun. And it's a really spectacular sight to see. Now the last thing I want to leave you with in Stellarium, before you watch some of the other videos we have that dive into more details about lunar phases and the ecliptic, let's look at what the galaxy looks like if we happen to be at a dark sky. So I'm going to go a little bit later at night. This is about 10 o'clock at night. We're looking in the same direction. You can see the moon and Saturn and Jupiter. And what I'm going to do here is I'm going to turn off the atmosphere. Now the way you turn off the atmosphere is you go up someplace high or someplace very dark where you don't see a lot of scattered light. And if you do that, you're going to see the Milky Way, which is the plane of our galaxy, passing overhead all the way across the sky. And it's a really spectacular sight. If you get a chance to go out to North Fork Park, you'll see a really good sight of this. It's a great time of year to see the Milky Way. And if you want to think about it for a second, here you've got on August 30th, you've got the moon, you've got Saturn, you've got Jupiter. That's the plane of our solar system. And you can see the plane of the galaxy cutting down through it, seeing the full three-dimensional view of our galaxy and our solar system together. It's a really spectacular sight. So I hope you'll get a chance to play around with that, get a chance to go outside and take a look to see what that looks like. And even if you happen to be in the city, you can certainly see the moon, Saturn, and Jupiter, which are spectacular objects to see in their own right. So I hope this helps get you oriented in the night sky. We'll do a little bit more with this later, and I will see you then. Bye-bye.